Question 19a. Two isolated sphere A and B are located on the x-axis of an xy coordinate system as shown below. The electric field at point P is directed upward along the y-axis. If the charge on sphere A is 8.4 nanocoulomb, calculate the charge on sphere B. So here we have sphere A, which has a charge QA of magnitude 8.4 nanocoulomb, which we can write as 8.4 times 10 to the power negative 9 coulomb. And sphere A is positive as the charge here has no negative sign, so we will take it to be positive. And the question says that the net electric field at point P, because of these two spheres, is along the positive y-axis. And we need to find what is the magnitude of charge on sphere B. Now, since sphere A is positively charged, electric field at point P will be directed away from sphere A and it will be along the line joining the two. So we can show electric field at point P due to A in this manner. I will call this as EA. Since this electric field does not lie either on X or Y axis, I can split this into its component. One component that goes along X axis, we can call this as EAX, and one component that goes along Y axis, which we will call as EAY. Now, if you want the net electric field to be only along Y axis, we need something that will cancel off this X component. So we need to choose charge on sphere B such that when I find its electric field, its X component must cancel the X component of electric field due to A. So we cannot choose B to be a negative charge because if B were negative, electric field at point B because of B will be directed towards sphere B and its component would happen in the same direction as EAX. That will not cancel them, it will add to it. Therefore, sphere B must also have a positive charge and its electric field at point B must go away from sphere B. And when you show its X component, it must be opposite to EAX. Only then they can cancel each other. So since the net electric field is only along y-axis, EAX and EBX must be equal in magnitude and opposite in direction. So we can equate their magnitude. I write EAX is equal to EBX. Let's call the angle these electric field vectors make with the x-axis as theta A and let this be theta B. Now theta A is equal to 45 degree whereas theta B will be 60 degree. Because these are formed between two parallel lines with an intercept. So if this angle is 45, this also has to be 45. Whereas for the other part, if this is 60, this one also has to be 60 because they form a pair of corresponding angles. So we can write for the magnitude EAX, I can write as KQA over RA squared. Since this is the x component and it's making an angle theta with the x-axis, I will write the x component as cosine theta A equals same for EP KQB over RB squared cosine theta B. Here RA is the distance of sphere A from point B. So I can find this distance using Pythagorean theorem. I can write RA to be equal to square root one side squared, so root 3 square will be 3 plus the other side squared, so again root 3 square will be 3. That gives you RA to be root 6. RB is the distance of sphere B from point P and we find this distance in the similar manner. We write RB to be equal to square root one side square which is 1 squared plus the other side square again root 3 square will give me 3. That gives you RB to be equal to 2. Now we can cancel off the common terms and substitute the values. So I can remove these k and we rewrite the expression as QA cosine theta A over RA squared QB cosine theta B over RB squared. We need to find QB, so let's rearrange everything and write in terms of QB. You can also use shift solve by substituting all the values here. So I write QB to be equal to QA into RB squared over RA squared into cosine theta A over cosine theta B. Now substitute QA is 8.4 times 10 to the power negative 9. RB is 2, so square of 2 will be 4. RA is root 6, square of that will be 6 into cosine 45 over cosine 60. So that gives you the value of QB to be 7.92 times 10 to the power negative 9 coulomb, or you can write this as 7.92 nanocoulomb. Now in part B, you have a similar question, but instead of finding the charge on sphere B, now we need to find the charge on sphere A, whereas the charge on sphere B is 8.4 nanocoulomb, which is 8.4 times 10 to the power negative 9 coulomb. And the question remains the same. The net electric field at point P because of these two charges is directed upward along positive y-axis, and we need to find what is the magnitude of charge on sphere A. Now again, charge on sphere B is positive because there is no negative sign mentioned there. So electric field at point P because of sphere B will be directed away from B. Then when you split this into component, you have x component and y component. So this is E due to sphere B. This is EBX and EBY. If you want the net electric field to be only along y-axis, you have to ensure that this x component is cancelled. So sphere A also must have positive charge so that its electric field is directed away from it at point P, and it has a component of x that is opposite to EBX. So we call this as EAX. This angle again will be 45 and this will be 60. So since these two x component must cancel each other, they must have equal magnitude and they must be directed opposite to each other. So I can write EAX to be equal to EBX. EAX can be written as KQA over RA squared cosine theta A, and this will be KQB over RB squared cosine theta B. Both components are attached to the angle theta, so when we find its magnitude, it has to be with cosine theta. We need to find QA, so let's rearrange the term. We can cancel off K here, and we write QA to be equal to QB into RA squared over RB squared into cosine theta B over cosine theta A. RA is the distance of sphere A from point P, and RA again will be found using Pythagorean theorem. So this becomes equal to square root one side squared, which is root 3 squared, that is 3, plus the other side square, again root 3 squared, which is 3. That gives you RA as root 6. RB on the other hand is distance of sphere B from point P. So again square root one side square, which is 1 square, plus other side square, which is root 3 square. That gives RB as 2. So we get this as QB is 8.4 times 10 to the power negative 9. RA is root 6, square of that will be 6. RB squared will be 4 into cosine 60 over cosine 45. And when you solve this, you get the charge on sphere A to be equal to 8.9 times 10 to the power negative 9 coulomb, or you can write this as 8.9 nanocoulomb.